Hello everyone. Could you please confirm if you can hear me well and see my screen? All right. Any questions from the previous classes? Have you tried to configure any of the server topics that we have covered so far? Do you have any queries that I can help you with? All right. So today we'll go through a quick introduction about shell scripting. We'll also go through some of the commands and features that we have covered previously, and we will also see some of the topics, some of the new topics under the shell scripting topic. So we'll just revise some of the older things and learn some new things, and together we'll try to come up writing some important shell scripts. First of all, focus on the fundamentals of writing shell scripts. Okay, so first of remember the beginning classes that we have covered, right? So shell is one of the important layer in the Linux architecture diagram. It is an interface between the user as well as your system, right? So shell basically helps to interpret your commands, execute them on the shell prompt, and they'll be sent to your kernel, and the output will again be displayed back on the screen, right? So this different types of shells in a Linux system. So we have quick question. Do you remember the name of the file that contains the different kinds of shells present in the system? So what is the name of the file along with the path that contains the different types of shells present in the system? So what is the shell that we are currently using? We are currently using so echo space dollar shell. One of the participants has answered echo space dollar shell will give you the name of the shell that we are currently using. Okay, and bash is the shell that we are using. So what is the name of the file that contains the list of all the shells? So it is cat space etc/shells. So that file would contain the list of shells present in your system. Okay, so we can switch. So if you can also find other shells other than the ones that are listed on the screen in this particular system. So they might also be supported on your version of the operating system. Okay, so different types of shells include C shell, KSH, TCSH, okay, etc. But most of the time you would find the bash or the sh version of the shell script of the shells present in the system. We'll be using either sh or bash. All right, so now another question. So what is the command used in order to switch between the shells? Remember the command that we use in order to switch from one shell to another shell? chsh is the command that we use in order to change the shell in the system. Okay, chsh is the command. So we say chsh space the path of the new shell. For example, chsh space sh will try to switch default shell from bash to sh. Okay, now just as an example, you can see me installing a new shell called ksh, which is a con shell. Okay, so this so every shell will have its own properties. So bash shell is one that is more user friendly with all the features like the tab completion feature. Okay, um, the reverse search, whatever that we are doing, different types of shortcuts to move your cursor. Okay, all these features are available. So in case you wanted to have more secure system, ensure that the commands that you are typing are not uh, visible to others on the shared system. Okay, then you might want to disable these features in bash, or you might want to use a different shell like ksh. So for that, you need to make ksh as your default shell for that particular user. And how this can be achieved? So when you are creating the user, if you remember the different types of arguments that we provide, it is possible to change the home directory of the user when you create a user, and even after creation, post the creation also, we can change the default home directory, we can change the default shell the user will land up when he logs into the system, right? Similarly, all these different values can be modified during creation and post creation also. So we have to change the default shell for the user. Then when he logs in, by default he will land up in that shell. Okay, so, quickly echo dollar shell. So bin bash. So chsh bin ksh. You see, okay, now we have a question. Even if we type ksh and enter, will it take ksh shell? Okay, let's take an example. Now, what is the default shell? It is bin slash ksh. This is a default shell, right? Let's type bash. You asked for ksh, I'm doing it for bash. It is successful. I'm able to land up in the bash shell when I type bash. Okay, so the answer for your question is yes. Now what is the difference? Okay, now you tell me what is the difference that you have observed. So even if you type the name of the shell, you can switch, and at the same time we can use chsh command to switch. Did you notice the difference between executing both these commands. You simply run the name of the shell like bash or ksh. You will switch to the new shell, but the change is temporary. The moment you log out and log in, okay, you will again be forced to use the default shell that is present inside etc password file. Grep root etc password, and see here, I'm just trying to press the right side arrow to move my cursor to the left, but it is just not allowing me. So I have to do control backspace, press control backspace to delete the lines. Since this is KSH, it will not allow me to move my cursor. I cannot, I'm trying to press the upward arrow to see the previous commands. Again, it is not allowing me. Control backspace to delete. Okay, so this is some one of the disadvantage of KSH. If you are looking uh, for a feature where you can check the previous commands that you have used, it is not possible. Grep root etc password. Okay, so it has updated bin ksh. Now another uh, thing with ksh is you cannot use the tab. Usually in bash we use tab to complete the name of the file, right? So we say grep root etc there. So while typing etc press tab, so it has uh, displayed this for me /t. So it is not that user friendly. Okay, so what I do now, so this is how you can change the default shell. I'm just changing it once again. Bin bash shell has changed. Again exit, or there itself you can simply type bash, then you'll get switched. So this is how you can uh, change shells, okay, the default shell for a particular user. Okay, so these are the different shells that are available: corn shell, CSH, TCSH, SH, bash. Okay, and I hope you have also observed the no login shell, which is primarily used by different system processes. That means there are some processes which are going to get executed with that particular username. Okay, so those users, they do not physically have a shell prompt. So you can look at such users inside etc password. So there is some daemon running for which there is no login. So you cannot log in as that particular user. So like that, there are a lot of processes in a Linux system that have no login as the default shell. Okay, now coming to the variables part. Okay, so we have seen three different categories of variables. Quickly to revise. One is the simplest form where you can assign some value to a variable and you can retrieve the value of that particular variable. So echo, so say x is equal to 2, echo space $x. X equal to some string, echo space $x. If you want to assign a line, all right, a bunch of strings, you need to put them inside double quotes and assign it to a particular variable. And when you want to retrieve it, you can do echo space $x. So these are the three simplest examples. Okay, so x equal to 2, and number, assigning a number equal $x. Similarly, x equal to some string equal $x. Similarly, x equal to put something that is space separated. Okay, so this is how we usually assign the variables and retrieve them. So this is the simplest form. So these are the next category that we have seen are standard input, standard output, and standard error. And we primarily use standard output and standard error. Okay, so standard output, so whenever you are running a command, so if the command has executed successfully, whatever output that is printed on the screen, that is your standard output. And if at all there is any error, like for example the file is missing, the file is not present, okay, then it will show an error message on the screen stating that the file is missing. So that is called as a standard error. So we can make use of these numerical representations for standard output and standard error inside the shell scripts. We can also call them as IO operators, input output redirection operators. Then we have another type of variables that we'll see in some time. So there are some 10 different types of variables. So they are, one of them is $, which would help you to know the exit status of the previous command. So using these variables also, we can capture some information in the system that that can be logically passed to the next line in your shell script. So a shell script is basically uh, a bunch of commands. Okay, so inside a file, so we have seen this example a couple of times. You can just include a command, one command per line, and you can run that script. Okay, you can execute all these commands one after the another by keeping them inside a script. Okay, so this is the simplest form of a shell script. So these commands, along with these commands, we can add a simple logic initially where we can have basic loops, loops. So then comes our system variables and special operators that we have seen before. So in order to move to the next level, what we do is we make use of these kinds of operators. So these operators will basically help us to add some extra logics, like only if a command is successful, then we would request the script to proceed to the next level. Okay, so you can have such kind of logics in place. Not only that, but say for example, you want to read inputs that are being passed to a script. You can write scripts that would get executed based on the user input. So there can be scenarios where we cannot predefine the values all the time. Okay, there can be dynamically generated values. So you may want to consider as an input to your in such scenarios. You may have to pass those values as an input to the script. Then we want to take those inputs and then process the script. So those are some of the additional requirements. And so other than this, we can also make use of different kinds of utilities. Okay, so when I say different kinds of utilities, so we have awk, SCD, and we also have uh, the grep command, fgrep command, egrep command, and uh, we have find command. Okay, so I think we have also seen some examples of using find command, right? Did I cover find? Did I give you some examples on find command? Oh, okay. So I'll give you some examples. Okay. So using find command, the simplest example is let's take a file. Okay. So find under / name password. So find command basically helps you to search for files in the file system. So the simplest form is the one that you're seeing on the screen. So what I'm doing here is I know a file named password, but I don't know where this file is located. Okay, so find will help me to search for a file called password. So the syntax is find under / so hyphen name space password. So this will look for this particular file under / directory. So this way we can, so this is the simplest form. So find can be used uh, for much complex uh, scenarios. Okay, so we can search for files based on the inode number. Uh, so so we pass something like, let's take another example. You see, what I did is I have just looked, verified the inode number of 018, and I tried searching for that particular file using the inode number. So it has displayed me the inode number. You can skip these error messages. Anyhow, we have the redirection operators in which we can skip them. So like that, so find command can be used for different so some of the other areas are, so we can search for files based on the timestamp. You remember the stat command that we have used? Stat will give you the stat file. So what was the time when the file was touched for the last time, and access time, modified time. Alright, so all these things can be uh, considered when you're searching for files. Or take a little more complex example. So say there is a directory, okay, and this directory contains a lot of files, log files, okay. So and so what I'm saying is I want you to periodically, okay, periodically delete the log files which are older than 1 week. Okay, so there what you have to do is you have to keep checking for the file stamp or for the last access time of these files, and based on that you have to delete those files. Okay, so for such scenarios find is an excellent tool or the utility. So here you can have those options. Let me show you. You can search for files based on the depth. That means the number of levels that you wanted to go inside for a particular searching, you can restrict yourself with respect to that. And some of the important ones. So -a-min, so which is like the file was last accessed n minutes ago. So you can say -a-min space 30. Say for example, you are looking for system that were accessed just before 10 minutes. Okay, so you might face such situations where some user has done some changes and you are not sure what those changes are, but you know that in the last X minutes some files have been updated in the file system. So you can use the find command and define an argument like -a-min space x, where x represents the number of minutes, and in the last x minutes, so you are looking for all the files that have been modified, and that way you can filter uh, filter and get the input that you're output that you're looking for. Okay, and then so like that we have c time. Okay, c minutes. You can also look for executable files. You can also look based on the permissions. You will have this argument called perm. Okay, here you can look for files based on the permissions. So I want to list all the files which have this particular permission, like that. If you remember the pipe operator, we can make use of the pipe operator in combination with these options, and we can filter the output and uh, generate a lot of information. So find is one of the important command that is used as a part of the shell script. So basically shell script is nothing but a combination of all these components. Okay, so the more you practice these utilities, the better your script would be, because we'll be making use of all these different kinds of utilities based on the use cases. So take this. So find, for example, slash home. Okay, and we see I'm looking for some permissions like 0755. Okay, 700. So these are all permission. Okay, so I just checked it to ensure that the output is successful. The output of the find command is successful. Okay, so you can use the find command this way. So there is also another way of using find command, like we can use the not operator. That means search for files which do not have this kind of permission. Okay, so for example 755 and find for this location, and if I say hyphen type under home, which is a file, okay, and I'll put a not operator. I'd say find under this location for a file type which doesn't have this kind of permissions. Then it will look for all the files which do not have 755 as the permission. So this way we can add filter in both the ways. Okay, either fetch me with this permission or either fetch the files with this permission. Okay, similarly we can also use the find command to search for files with much granular uh, inputs, like search for files uh, whose groups will have permission, or which have a sticky bit set. All right, like that. Then we can also there is also another use case of find command. Okay, so this use case is where we can search for a set of files, okay, and then similar to the pipe command that we have seen, right? So output of one passed as input to the other. Okay, we also have such kind of functionality in find. Uh, let's take an example. So I've taken and let's say I'm using find, okay, find under dot, and I'm looking for file type, okay, with permission. So what permission we have? It is 644. Okay, we got all the files. Perfect. Now we can use this format like, okay, there is something called exec. So once you print it, so exec is similar to a pipe operator, okay, and we say execute this particular command, okay, and say 755 to this output. You see the difference? Please make a note of this particular command. It is going to be very useful for you. So different use cases similar to the pipe operator, find can also be used here. Here instead of doing chmod space 755, if you give a remove command, so rm-r, then all the files that are matching these permissions, so they will be fetched and they will be passed as an input to this exec command, and whatever command lies here, it will be applicable on those files. So here if you put rm-r, then it will search files with this particular criteria and it will remove all those files from the system. So the same concept can be applicable, can be applied where you are searching for files with a specific timestamp. So I'm looking, so find files which are older than 30 days. Okay, so you can use the corresponding argument here, and whatever output comes, pass it to exec and remove it in one single line. You can delete all. You can implement that use case. So it's like finding and removing the files. Okay, similarly, uh, you can look for empty files in a system. You can look for empty directories. We can also look for hidden files. Remember hidden files? Files that start with the dot. Files that start with the dot. You can have hidden files. You can have hidden directories. Okay. We can also search for files based on the ownership. Okay, and who the owner is, based on the access time, based on the modified time. Okay, these are some of the examples of find command. So using all these different variations, we can also search for files based on the file size. Okay, if the size of the file we have, I think it is size. Okay, hyphen size. You can use hyphen size as an argument and say that search for files which are greater than 15 MB. Okay, so then you can also use hyphen exec additionally in order to apply other commands after you perform the search. Okay, you can search for files, you can search for directories. Okay, so like that there are a lot of options available with the find command. Find is one of the very important utility we have. So like this, okay, use this make use of the SCD command. You can make use of the grep command, egrep or fgrep variations. You can use the awk command. So we have seen some examples. You can further do a deep dive on the different use cases, and uh, using them you can come up with some better shell scripts. Okay. Now moving further, so these are some of the variables, system defined variables and user defined variables. So if you say x equal to 2, that is a user defined variable, and equal dollar question mark is a system defined variable. Not only that, but we also have some of the variables, right? Like uh, the default home directory, what is the default shell. So you can run env command in order to list all those variables. They are also your system defined variables. Then you know how to retrieve the variables. So the process is the same: echo space dollar name of the variable. Okay, and so before proceeding to the next topic, which is on different kinds of loops, we'll quickly just see how to execute the shell script. So every file will, as you know, there are different types of permissions, right? And also they are applicable for different types of users. So one is the owner, then we have group, and then we have others. So as long as you provide execute permissions, you give execute permissions, so users will be able to execute the script. The moment we give execute permission, here the color of the file gets changed. See, all the three, they have execute permissions available. So as long as we have the execute permission applied, so users can execute the scripts. Okay, and you know how to provide execute permissions using chmod. We can give execute permissions at a user level, group level, as well as for others we can give execute permission. So every time we write a script, okay, the script basically starts with sorry, it starts with a shebang operator, which defines the name of the interpreter, okay, the shell interpreter using which the script will be executed in the Linux system. So we start the script with a shebang operator, and then we include the list of commands together with loops, variables, etc. And once this is done, you give execute permissions to the script. Okay, I'll just follow this format once again for a simple example. So there is no convention, no hard rules that a script must have a specific extension, but it is recommended to use the extensions which will make this script, readable, and at the same time, understandable for others. So usually scripts will end with .sh shell scripts. Okay, if you open a shell script, so I'm trying to create a shell script with .sh extension, but it is not mandatory but recommended. And insert shebang operator hash exclamatory bin bash is the shell that I prefer. And starting with some basic commands, I say echo defining a value for x. I say x equal to 2, and then echo printing value of x. Okay, and then I say echo $x. Now go checking exit status of previous command, echo $?. The reason I'm showing you the echo statements, so many echo statements, is because echo statements are used, okay, in order to uh, make the output readable. So before you are printing something on the screen, you might want to put an echo statement that tells so what is happening in the next step. Okay, that we'll see. So I have added some content to the script. So now what I do is chmod +x script.sh. Okay, then you see. So these echo statements, they help us, to make the output more readable. So printing value of x is 2, checking exit status of previous command, which is 0. Okay, so echo statements will help you a lot while writing a shell script to make the output much readable. So try to use echo statements wherever you find them useful. So we can run the scripts in different ways. So one way, as you have seen, /script.sh, this is one way of running the scripts. You can also source the script. Okay, so say source space script.sh. Okay, uh, I'm just telling you the different types because you might find such kind of implementations in different places. You can also say bash script.sh. Okay, and you might have scripts with sh also, sh space script.sh. So these are the different ways in which you can execute your shell script. Okay. Now just one additional important thing here is uh, I'll just mention it now. How do you when you debug shell scripts? Okay, when you want to debug. So one of the important argument is bash-x. So bash-x is to run the shell script in debugging mode. Okay. So either you say bash space -x space script.sh. You can see there is a difference in the output, right? So this is called as a debugging mode. Either you can mention it like this or inside the script. Okay, in the end of the line you say -x. Okay, now if you execute the script, even then it gets executed in the debugging mode. So this way basically you are hard coding that mode. Rather you remove it inside the script and you can mention it in the to do. So it will print each and then it will print the corresponding output that it is about to display on the screen. This is how we can troubleshoot. This is just an example that I wanted to mention now. As and when required, we'll explore other options as well. Well, so far, you know that a shell script has basic commands. We started to provide execute permissions to the script, and we make use of the system variables, user-defined variables, special variables, IO operators, and we make use of loops. So we'll get into the loops topic, and there are also concepts on arrays. We can also use the concept of arrays in writing shell scripts. Okay, and I would say a little advanced topic would be writing functions. That means if you are familiar with other programming languages, so you define a function inside which you perform an operation. Okay, and then you call that function in a different place and generate the output or implement it for a different use case. So functions are also available inside shell scripts. So there is a limitation to shell scripts. A shell script is not a programming language. Okay, a shell script is not a programming language, but it is the simplest way of to perform certain kind of operations in a Linux system. So shell script enables you to implement or to automate some of the things in a very shorter span of time. So that is why we go with shell script. But a shell script again is not a programming language. So it is, so depending upon your use case, you choose whether you wanted to go with a shell script or you wanted to implement it as a program in your system. Okay. So some of the use cases where these are the shell script is widely preferred is with respect to automating the manual jobs that you perform uh, on a day-to-day life, on a Linux system. Some of the admin jobs, they are automated, and requirements where you might want to process the data, perform some data crunching. Okay, so using these utilities that we have, or maybe examples where you might want to keep clearing your log files, compressing them, rotating the logs. So we have seen such examples where shell scripts are used in order to take care of such kind of jobs. Okay, it takes a very less, comparatively less amount of time. Quickly write a script. Even the conventions are very less. There are no hard rules present when implementing the scripts. So this is how we execute and debug the scripts. Okay, are the things that we are already the basic loops. So by making use of the loops, we can create conditions. Okay, so with respect to loops, you need to be a bit careful when providing the spaces with respect to the syntax. Okay, so if you take starting with the if loop, we can have if loop which says if file, then execute this file. Okay, so if x equal to 4, then echo $x file. Okay, so that is a very simplest form of the if loop. Then you can also have an else statement added. That means if x equal to 4, then execute echo $x. Else, so if x not equal to 4, then what I should do? Else is the statement where you put something else. Else quit, or else x equal to 6, or add x plus y, some other operation. Okay, so that is the next level of if loop. So if some condition matching, do this. If some condition matching, do this. If it is not matching, do this. Okay, so like this, it is I feel it as a method of adding more filters. Okay, in order to kind of go deep into the data based on your requirement. Okay, so or let's take a different example, uh, like there is a variable called x. Okay, and x can possibly have values ranging from 1 to 100. That means x can have 1, x can have 52, x can have 74. Okay, now the first requirement is if x, say for example x is equal to 74, if x equal to 74, then send an email to this user, the simplest form. Okay, then I say if x is not equal to 74, then send an alert. Okay, so do you put a statement saying if x equal to 74, send a mail. If not, else in the else statement, if x not equal to 74, then send an alert to all the users. Then I say uh, I want to put an additional logic saying uh, check the value of x. Okay, if it is equal to 74, fine. Else check if the value is less than 50 or more than 50. If it is not 74, check if it is less than 50 or more than 50, because I have some other uh, business logic over there. So what I would say is, if it is less than 50, then send an alert to this particular group. If it is more than 50, send an alert to this particular group. So that is where you have an extra filter coming in place based on the requirement. So there what you do is, so that is where we start making use of nested if loops. Nested if loop means keeping more conditions. So if x equal to this, then do this. Else if, okay, L if, ELIF, L if, okay, if x equal to this, do this. L if x equal to this, finally else do this. So you can have, so this is what we call as nested if loop. Okay, if you have lot of conditions, then you keep adding those conditions inside the nested if loop. Okay, so this is one of the important use case where you can make use of the if, nested if, else, elif, all these different options that are available with the if loops. Okay, so this is see some examples as well. Okay, now here it's a simple script that you can see bin bash for if. So the number assignment, variable assignment has been done. Num1 is equal to 10, num2 is equal to 10. So apart from the if loops, variables, okay, so we have something else, operators. Okay, now what is operators are? So when you are when you want to implement a specific condition, then depending upon the condition, so it's like matching the variables, check whether uh, these two variables are matching, $x equal to $y, or we want to perform the opposite way, check equal to $y. Okay, or what you want to do is check whether a file exists in the system or not. If it exists, then perform this operation. Okay, uh, so this is one of the real time example, I would say. So once I've been asked to uh, write a small shell script. Okay, so I usually suggest this to everyone. So this is how the question is. So in a particular directory in a Linux system, okay, uh, a file gets copied from a server to this particular Linux system in a particular folder. A file gets copied every day. Okay, so we are not sure at what point of the day the file gets copied from server to this particular machine. So basically what you have to do is you need to write a shell script, okay, that keeps checking for this file in this directory, and the moment the file is present, you have to notify a bunch of users that the file has arrived. Okay, so the user will give you the, you can have different types of files, and when this use case, this question has been asked to you, then you can ask for situations like there can be different types of files, so there must be some identification for the file that comes into this folder, right? That is how you identify. So you can ask for the file name. So uh, will I be given the file name so that I can search, I can look for that specific file, or otherwise how do you identify the file? So if I tell you that okay, ABC is the name of the file, then you can have an if loop stating an if loop or some condition where you might want to check whether this file exists. So inside the excuse me, inside the if braces, you can have a condition like -f file name. Okay, So -f means if this file exists. Similarly, you can have a condition like if the directory exists, if uh, you know you can have one condition, so that I will give you that test. Yeah, so please make a note of this particular condition. So it is called as test. Okay, so inside the if loop here, the braces, the rectangular braces that you're seeing, okay, so they are called as test. So if test this logic, okay, so if you want to know all the options that are available here, like, so equal to here symbol represents you're checking whether this variable is equal to this variable. You can have uh, a comparison, numeric comparison. You can have comparison between strings. Okay, there can be different types of comparisons you will be making. You will be checking whether a file exists or not, whether a directory exists or not, whether it is an empty file or whether it is a integer. Okay, like that, different conditions would come into that inside the braces. Okay, we call it as test. Okay, you can also say by removing these braces, you can say if space test space $1 equal to $2, or instead of that word we replace it with braces. Okay, so look for a man page called test. Inside this man page you can have different expressions. See the negate operation. uh, you can also simply put braces, which means if this is true, like if inside braces if you specify number 1 which is greater than 0, which is non-zero, any non-zero number is considered as true. Okay, so then the expression becomes true, it will go inside the loop. Okay, so that way you might find examples also. So go through this, all these options that are available, they are very very important. The test conditions, matching strings, equal to, not equal to, greater than. You would have all these different kinds of examples. If this number is greater than this is less than this, greater than equal to, less than equal to, right? Not equal to, all the options. File exists and it is a directory. If a file exists, if it is a regular file, if it is a character special file, block special file, all these options are very important for writing if loops. Okay, you can also check based on the permissions, okay, etc. So remember this, it is called test. Go for the test page of man command. So you can use all these options that you have seen just for writing an if loop. Okay, so when you practice, start an if loop, start with this numeric representation, use the syntax print, then take another example. So you can just refer to that man page, then do the string comparison. See how to do the string comparison, where you have to use hyphen EQ operator, where you have to use double equal to operator, where you have to use a single equal to operator. Okay, so these are all the different kinds of operators that you can make use of when you are implementing these loops. Okay, so this is one example. So if this condition is matching, then execute it. Strictly you have to follow. So another advantage, another I would say methodology, I would say the very recommended approach of writing good scripts is to quickly test it out on the command prompt. Okay, that means here the same one, x equal to 2, y is equal to 3. Okay, and I say if, so everything that you execute inside the script can be done here on the prompt itself. Okay, so if $x equal to $y, then if it is equal to, then echo success file. It has failed because $x is not equal to $y. Okay, so this is how we can test the strings on the command prompt itself. Now I have changed it to not equal to. Okay, so any logic that you want to come up with a big script, come up with the list of steps what you want to implement. For each step, mention the logic that you wanted to have in place. Take that logic piece out of the script, run it on the command prompt. Okay, so here I just have to assign two variables along with this logic. Do it on the prompt, test it out. It's working, then put it inside your script. Then take the next piece of logic that you want to implement, put it on the prompt, run it, test it, then put it inside the script. Okay, so always running the logic on your script would simplify, and it will fetch the proper output for you when you are executing inside the script. That would help you to reduce the troubleshooting work that you have to do after implementing the script. So it goes the other way around also. That means someone has given you a script and say that this is not working, so you can follow the same process, break the script, okay, into each individual logical operations that we are performing. Take each of the operation, execute it on the command prompt. Okay, when troubleshooting, add some additional echo statements inside the script. I give you a big script and say it is not working. How do you troubleshoot? Go through the script. So with every operation, some output gets generated, right? So put an echo statement after that. So try to generate value, print it on the screen while testing. Okay, then follow the output. Uh, See where that value goes next, then again print a variable, so that follow that order. So that way you can troubleshoot. So include echo statements wherever possible. So usually when you are writing a script, you might put additional echo statements, but when you are executing that script, okay, you may not want all that many echo statements. So you may not want the user to be aware of that many things on the screen or inside the logs. Then you might simply comment out. Okay, so then remove the comments, use the echo statements to print the values, what values are getting generated, what values are being passed from one step to another step. So echo is going to be very useful for you in those cases as well. Okay, so here is another example where we are using if condition, then do this, else do this. So are you clear about uh, an overview of the shell scripts, the important components of shell script? I know there are uh, some of the options that I haven't covered, but at least I gave an overview, like for arrays, functions, so rest of all the elements that we have covered. So if loop, how it works. So what are all the different options that are available with if loop? What are the man pages that you have to refer to? And the example that you have seen, how to implement them on the command prompt, how to debug them, how to make use of the echo statements. So any questions so far on these areas? Are you clear so far? Let me know if you have any questions. Okay, sure. I have one question about xargs command. Yeah, we'll go through that as well. Others, are you following me? Uh, just give me 1 minute, guys. I'm gonna keep you on mute. So try the examples of loop that we have covered so far. Now we'll move to the next loop, which is for loop. The syntax. I hope you're familiar with the syntax. For so x equal to, so this is where we perform the assignment, and then we check the logic. Based on the logic, we implement it. So for example, x equal to 5, check whether x is less than 10. If it is satisfying, then implement this. Okay, which is decrementing this particular operation. So I'll take a quick example here. So this is kind of a different implementation for if loop. So you can say for months in, so these are the different options. Do echo month. That means, so it is like for X. Okay, months means this word is nothing but a variable. Okay, so for variable in Jan, so that means the value of Jan comes here. So, so for Jan, do echo this particular something. Then it will go back for the variable value Feb. It will execute this. Or you can take a simplest example here for, so you see this. So what is happening? So first of all, for x equal to 1, it will go inside it will execute echo $x. For x equal to 2, it will go inside execute echo $x. 3, it will do it. The same thing here. Instead of x, we have months, and instead of single value, we have other options here, and it will execute this particular script for you. So this is one way of a different way, I would say, of quickly implementing the for loop. If you have uh, you know a unique set of values which you cannot loop in, like the previous syntax that you have seen, this is more this suits more for cases where you have specific numbers and you want to check for a range of numbers and then keep incrementing or decrementing the numbers. This is where you can use strings also in order to make them part of your loop. Okay, so when you execute, so this is how it comes. So inside this particular variable, you can see, so the value of I keeps on incrementing, and I is equal to 1, the declaration has been made in the beginning, and it keeps on incrementing. So this is how it increments. So these are the different special variables that we use. Please make a note if you don't have this list. So $? is something that we have already seen, and the process number of the last background command, $! the process number of the current shell. So some use cases, if you're looking for, maybe you're running some script, so usually it is possible to fork a new shell and then execute. So whenever we are executing a shell script, so what it does is it will generate a new process, it will fork a new process, new shell, and it will execute it on that shell, and you might want to kill that sub process. So that is when we use this particular $$ value in order to kill that particular process. Similarly, with respect to arguments, okay, as I said, say for example you are doing /script.sh, and then you pass 3 arguments like space1, space2, space3. So these 3 are arguments to that script, and inside the script you can call these arguments. So echo $1, echo $2, echo $3. So these are the 3 arguments that you have passed. You can also say echo $#, which will give you the number of arguments. Some scripts you can have a condition in the first line stating that so it is mandatory to have 3 arguments to this script. So first of all, you check the logic, like if $# not equal to 3, exit and print a message. You have to pass 3 arguments to this script to execute if the number of arguments is not equal to 3. Okay, so like that. So for such scripts, you can check the arguments that have been passed and execute the script accordingly. So that is where we use the $#. Similarly, you can make use of all these variables in the scripts. So here $0 is represents the name of the current script. So this is something that you can use when in the first line itself. If the number of arguments are not matching, so execute. You need to execute rather than mentioning the script name. You can say $0. Okay, so that helps you uh, to reduce the number of characters that you're using, the number of characters you're using in terms of writing the script. You can shorten your script, make it small, rather than hard coding everything inside your script. Okay, so then arrays in a shell script. Well, okay, we have one question here. So I gave you an example regarding the find command, right? Yeah. Okay, you take the same command. $755. Now they are changed to $755, right? Okay. Now tell me, did this example answer your question? So the question is how to make use of exarchs in Linux. There can be multiple use cases of using exarchs, but does this example, gives you an understanding of how we can make use of exarchs? Who asked me this question? Ramesh. Okay, so I said .exe is like, you can use it like a pipe symbol, right? Yeah. So it's the same thing. So rather than using it this way, you can put a pipe symbol, and you can use exarchs in order to implement it. You can have additional uh, options available with exarchs. You can go through that as well. Go through the man page and see what other options are available. How sorry, different ways of using exarchs. So just try it. We'll go through other options as and when necessary. Okay. The next one is arrays in a shell script. So so far we have seen storing values inside the variables, right? So other than storing a single value inside a variable, so we can store a bunch of values inside. Okay, so this comes under the concept of arrays. Rather than storing a single value, you can store more than one value, and you are storing it as individual elements. So you can also say x equal to inside double quotes 1 2 3. If you put double quotes here inside braces rather than braces, so this becomes a string, a single word, which says 1 space 2 space 3 will become a single word. Rather, what you can do is, if you want to store them as 3 individual elements, okay, inside this uh, array. Okay, array. So forget about the naming convention. It can be anything which we call it as an array. So array is a different kind of a variable that stores a bunch of elements. Okay. So here, how these elements are stored. So uh, the array will have this order, like uh, the elements will start like, you can imagine like it's a container. Okay. So if you have stored 3 elements, so the order starts with the 0th place, 0 1 2. So array of 0 is the first element that has the first value that you store. Similarly, it goes that way. So 3 elements will be stored in 0th place, first place, second place. So the number of elements in the array is 3. You can retrieve the elements by writing a small loop for that particular array. And the important part here is, so how do we differentiate between the array and the variable? One in which you assign the values. Okay, so here you say array is equal to 1 2 3 and you have declared it. So declare space hyphen a array name. If you mention this at the top of your shell script, then automatically this particular name will be declared as an array, and whatever you store will go into the individual places inside that particular array. So there are so array is kind of a little big concept. There are different ways. Maybe if time permits, we'll go through arrays. We'll allocate a day session, 1 hour session for arrays only. We'll take different examples. Okay. So when you particularly work on files with specific numbers, all right, and you wanted to implement logics inside, where you wanted to store some, for example, uh, a particular generated some 100 values, and you want to store these values inside an array, and you want to retrieve, you want to perform some logic for each of these values that is stored inside the array. So that is where the use case becomes complex. where you wanted to store, retrieve the elements of the array. So what if you want to compare the elements to arrays, comparing two arrays? Okay, so like that, so the use case would keep going. So I've just given an introduction on the arrays. So I would suggest that you go through the topics that we have covered so far. Try some simple examples: exec, xargs, find, all the utilities that you have learned so far, trying to combine them along with basic loop, if loop, and for loop. At least practice those cases, and we'll try to have another session on the shell script, so that meanwhile you can practice, and then we're ready to proceed with writing some scripts. We'll take some examples and try to implement those scripts if time permits. I'll also give you some more examples on arrays and functions. So with that, uh, I can see we have covered most of the important things with respect to the shell script. Okay, so the redirection operators is something that we have covered, and we'll try to use these operators as well in implementing the scripts. Okay, so, with that, I would like to wind up today's session. If you have any questions, let me know. I can help you with your queries. We'll definitely try to have another session for scripts, but please do practice all this, and you can be ready to take more inputs with respect to this particular topic. All right. So that's all for today. If you don't have any other questions, maybe we can wind up the session now. Please let me know. All right, everyone. Then see you in the next session. Okay. We have next session after 2 days. Well, please go through the topics. I would definitely want you to ask me questions. We can discuss on the topics that we have covered so far, or any other real-time scenarios that you have. I can help you with. Do let me know. Okay. Have a good day. Thank you for attending the session. Bye. Take care.